And hopefully we will be getting the recording with the attendance list from you guys. Okay, brilliant. Okay, hi everyone. Once again, we're moving to energy topics for Project ARC, and we're happy to shift into our master partners. And Maya and Emina, you're organizing today's talk, which is a very interesting talk on smart grids and how smart grids can help us with energy efficiency. It is a critical topic, and we hope that we learn even more from our guest speaker. So I'm not going to delay. If Maya or Emina, if you want to do the introduction of the speaker, and I'm looking forward again to questions following the talk. Thank you.
Thank you, George. So our today panelist is Dr. Tarek Hubana. He holds PhD degree in technical sciences, electrical and electronic engineering for Technical University of Graz, Austria. Since 2018, he is with the public enterprise Elektroprivreda of Bosnia and Herzegovina as expert associate of measurement and losses. At the moment, he is also an industry expert lecturer at Sarajevo School of Science and Technology. Tarek has been engaged in various fields of power engineering. His area of interest are renewable energy sources, power system analysis, microgrids, artificial intelligence, power system protection, software development, and simulation. So, Dr. Hubana, the floor is yours.
Thank you, Emina. So just a quick check. I hope you can hear me quite clear.
Yes, we can.
Okay, so thank you for your nice introduction.
We want to share the camera as well. Sorry for interruption, but because we cannot see, are we going to be able to see Dr. Tarek Hubana or just audio? Just to be.
We can see him.
My camera is on. Yeah.
Yes.
Oh, so it's my problem. I cannot see him. But anyway, okay, yeah. Okay, no worries. Please continue. Sorry, I do apologize for that.
Okay. So good afternoon, and today we will talk about one quite interesting topic, which is actually assessing possibilities for more efficient use of energy by improving energy efficiency through smart grids. Just a quick check. I hope you can see my screen right now.
Yes, we can.
Okay, so as Emina introduced me, I work and have worked into various fields related to energy through different sectors, academia, industry, and volunteering. And today we will talk about this interesting topic of energy efficiency through smart grids. So if we take a look at the world today, the world is better now than ever before. And how do we know that? If we consider the world as a planet with 100 people and follow the trends along the years, we can see that extreme poverty, basic education, vaccination, literacy, child mortality, and democracy, as we can see on the right-hand picture, are getting better and better. And how are we able to do that? All of these quantities now can be measured, and since they advance over time, this is called advancement. But when we consider our standard, today most of us live in a home that has air conditioning, we have a color TV, we have a running water, most of us own a car, and we eat more calories than we should from a variety of food. If we compare our standard today with the standards throughout history, we could compare it with the standard of the kings in the medieval. So the technology is the key feature to all of this progress. So one interesting off-topic is, are we maybe today cyborgs? Because by definition, a cyborg is an organism that has restored function or enhanced abilities due to the integration of some artificial component or technology. So every one of us who wears glasses, for example, we use the technology to improve our vision. We may consider that person a cyborg. Everyone who has a fixed teeth with today's technology is considered a cyborg. And also, even if we use our mobile phones as an extension to our brain, we can faster process information, we can Google things. That's also a feature of a cyborg. But how did we manage to move to this important step? One of the key features is electricity. So when we talk about electricity, electricity is quite unique commodity because it cannot be stored. It's highly influenced by other commodities, and demand and pricing depends on the season in the daytime, as we will see throughout this presentation. So electricity needs to be supplied immediately. There are limited applications where we can store electricity, such as pumped hydropower plants or battery storage, but they are not that common in the usage. So unlike any other material or type of commodity like oil, crops, and metals, the delivery period for electricity is actually 0. So to go from the beginning, how this whole boom around electricity started. So Thomas Edison, in the September of 1882, achieved a vision of a full-scale power station with a system of conductors to distribute electricity to the end users, to the high-profile business district in New York. So in the beginning, the electricity was considered as luxurious, and only the privileged could have it. So in the beginning, the initial load of 400 lamps, simple lamps, at 82 customers were served. Just 2 years later, 508 customers with more than 10,000 lamps were served because people realized that electricity is useful. And throughout the history, we advanced really much. So today, we have these large-scale power plants, like coal-based power plants, large dams that are used for hydropower plants, large nuclear power plants that we have today. And of course, at the end, we have these renewable sources of energy. By utilizing these different types of power plants, we came to the point where we need someone to operate that system. So at the right-hand side, you can see that we now have regulators called system operators that operate these various power plants, hydropower plants, wind power plants, solars, nuclears, thermal power plants. And we now have different types of consumers, different types of loads. So we have industry, households, railways, and so on. These system operators at the beginning were imagined as system operators within one country. But eventually, multiple system operators appeared in the neighboring countries, and the necessity for connection of these operators appeared. So today, most national system operators are interconnected together. And in that manner, a largest electrical network is created. So today we see a large European interconnection where all of these system operators are connected together, and we have a large scale power system. So that's how the power system scaled up. But now when we want to consider how the power is delivered to each and every of our households, we need to scale down again. So if we look from the left to the right side of this simple scheme, we have, of course, the power generation. We generate electricity by any of these means I mentioned earlier. Then we have a substation transformer, which actually rises the voltages up to the transmission level. And then we use the transmission lines, these large lines you probably saw in our neighborhood, where the electricity is transported over long distances at high voltages. But these voltages are so high that we cannot use them in our homes. Therefore, we have substation transformers, which lower the voltage. Then we have the distribution lines that in most of the urban areas are underground, but in the rural and suburban areas, we can see them on the wooden poles. And finally, this electricity arrives to our home. So traditionally, the flow of power goes from left to the right of this screen. So from the power plant to our household. Of course, in this step of the production electricity, of transport, in transformation of electricity, electricity emits a lot of greenhouse gases, primarily CO2 emissions, which are actually taking over 40% in total generation of greenhouse gases of CO2 comes from the electricity and heat production. And of course, large countries with developed industries, with large power plants, take up the most. So the China, United States, and EU take more than half of these emissions. When it comes to the electricity sector, of course, the coal is the worst way to produce electricity. Then we have oil and natural gas. So these traditional, conventional fuels used to produce electricity. On the other hand, in the past couple of decades, renewable energy sources started to show up, and the technology led us to the point where they can be an important player in the energy market. So as we can see on the left hand side of this slide, in the past 15 years, we have an increased portion of wind, of solar power, of hydropower, and a decrease in coal. Because of the price on the one hand, and because of the regulation and policies on the other hand. So today we have almost 30% in a global portfolio of renewables production. Most of it goes to the hydropower because it's still quite convenient to use, but wind, biopower, and solar power are starting to break into. So by having these technologies, by having these renewable sources, and by advancements of digitalization, of informatization, of all kinds of our life spheres, this also started to happen in our grids. And then we arrived to the point of the smart grid. So by definition, the smart grid is a modernized electrical grid, a both transmission and distribution infrastructure that is reliable, secure, that can meet the future demand growth while intelligently responding to the behavior and action that happen with that grid. And finally, delivering the electrical energy to the end customers in a reliable, efficient, economic, and sustainable manner. So since most of you here do not come from a purely electrical or technical background, I will try to keep these key features as simple as possible. But of course, if you have some detailed question, we can do it in the end. This slide here shows a quite traditional grid. So we have the utility grid, the transmission grid on the left side. We have that substation or distribution transformers we talked about earlier. And then we have our lines throughout our cities and neighborhoods that supply the energy to the residential consumers and commercial and industrial consumers. So in this setup, it is quite clear that energy flows from left to the right. However, in the past couple of decades, most of the commercial and industrial consumers started to have their own backup generators. Even distribution system operators started to install these backup generators. Renewables kicked in also. Most of the houses now have solar panels on the roofs. They have small-scale wind powers. They have different renewable energy sources that can give power back to the grid. And also, electric vehicles are becoming a big thing right now. So by estimates, in even near future, we will have a lot of electric cars parked and charging in front of our homes. And finally, Still not developed enough, still quite expensive, but storage is also one important factor. So large-scale batteries, for example, the company Tesla that produces cars has the largest scale grid battery located in Australia. You can Google it later. So this is becoming a thing too. Now, when you take a look at these different components of the grid, we can see that most of these new components can give energy back to the grid. For example, generators, they can give energy back to the grid. Electric vehicles, they can both charge and discharge by putting energy back to the grid. Storage also, renewable energy also. So now in the new setup, we have an energy flow that happens within the grid in the most stochastic way. So it is not traditional. We are not seeing the pure flow from left to the right. Now we have these contributions of each of these elements in the grid. And that grid is becoming quite hard to operate. So the distribution system operator is actually the company that operates the grid. In our country, we have 3 large distribution system operators. The largest one is Elektroprivreda of Bosnia and Herzegovina, and each country has this distribution system operator. Therefore, distribution system operators are trying to use new ways to control the grid. However, with the advancement of technology, of new devices that are now present in the grid, this can be quite easier. So in the next following slides, I will present key components of the smart grid that are helpful to control the smart grid. So first one is the advanced metering infrastructure. So if we look to the left side, I believe that most of us have seen this simple induction meter. And now we are having smart meters in our grid. Even in our country, we have more than 120,000 these smart meters installed. These smart meters can remotely measure energy. They can disconnect the consumer. They can manage the load at the end consumer and so on. And at the distribution operator side, we have the communication infrastructure and operating infrastructure. Another key component of smart grid is demand response. So to break it up, simple demand response is a way of controlling the devices at the end consumers. So when in scenarios when there is not enough energy or it's too expensive to produce more energy, the system operators can send a signal to a consumer that can actually turn off some of his devices. In this way, the end consumer can have lower bills and the system operator can have a stable system. So this is one of the future concepts. As well, it will be probably introduced as a dynamic pricing, so no more single or 2 tariffs that are most common in these areas. Electric vehicles, of course, they are a key component to smart grids. Why? Because electric vehicles with a specified 2-way chargers can both consume energy from the grid and push energy back to the grid in the cases when it's needed. So for example, let's imagine this scenario. You live in a neighborhood where 10 of your neighbors have electric cars, and the blackout happens, and this smart grid can use the energy from the cars to supply this neighborhood and keep the energy up while the energy from the primary grid restores. So also one component, if operated well, that can contribute to the more efficient grid. The next one is wide area situational awareness systems, such as wide area monitoring systems, such as SCADA systems. These systems with a number of components of measuring devices, of communication infrastructure that is installed in the grid can help us actually to get a real feeling what is happening within our power grid. And of course, distributed energy resources and storage. As we can see on the left side, already seen in a couple of pictures, the traditional flow of energy from the power plant to the end consumers. And on the right side, we have this number of distributed energy resources, which are in most cases based on the renewables. And we have these bidirectional or multidirectional flows of energy within our grid. And one important feature is, of course, the distribution grid automation. Currently, most of the old grids are operated by the personnel, by the manned crews that need to go out somewhere. For example, let's say a large fault happens in the one part of the city, and that part of the city is without energy. So you need to take a crew, get a car, and go to fix that fault. In a automated and fully automated grids, and with all these sensors, you can sense where this fault happened. You can remotely and automatically isolate that part of the grid that is having a fault, and then all of the consumers around that fault can continue to have supply until the fault is fixed. So one important feature of the smart grids as well. However, besides of these technological advancements that led to the development of smart grids, there are also geopolitical drivers, because I put three important ones here. The global energy demand is expected to grow for 100% in the next 10 years. As we saw previously on the slide, 40% of greenhouse gas emissions account for electricity production. And one important for this presentation is that the cost of generating a kilowatt hour of energy versus a cost of saving a kilowatt hour of energy through efficiency is 270 times fold. So that means that it's really important to keep saving an energy. And how can we do that? We can use energy more efficiently. So energy efficiency is the answer. However, when we saw these key components of the smart grids, now we can talk, how can we improve energy efficiency through smart grids? So here I put a couple of points. So it's through bulk generation, where we can use large renewable plants, through transmission, distribution, customers, operation, market, and service provider. Now we will see how. So through bulk generation, the plan would actually be to use more efficient plants, or even to use the renewable plants in order to pursue both energy efficiency and sustainability. Here in these pictures here, we see some of the new age power plants, which are actually pumped hydro power plant. That is the hydropower plant that can use the energy from the upper reservoir to produce energy and pump this water back to the reservoir in periods when we have excess of energy in the system. Actually, we have these hydropower plants are really rare, and actually we do have one here in Bosnia near Mostar in the city of Čapljina. The next one is biomass. So biomass, even though it is wood, basically, it is considered as a renewable energy source. By transforming our current coal-based power plants to biomass, and by sustainable growth of this biomass, we can also achieve more efficiency. And geothermal power plants are also becoming a thing now, of course, in the places where you can use this, such as northern places like Iceland, for example. The next way to achieve energy efficiency is more efficient control of the transmission system. So how can we do that? We can do that through different devices we presented earlier. So at the transmission level, so if you remember from the beginning of this presentation, those are the high voltages. These high voltage systems are managed through either SCADA systems or wide area monitoring systems. These systems use devices called PMUs, actually, which stand for phasor measurement units, and that are shown on the right side of this slide. These devices give a value of phasor in a point of the system, coupled with the GPS location and time. So in that manner, you can have a really good insight of what is happening in your system. And by having a really good insight what is happening in your system, you can operate it more efficiently. Most of the transmission system operators, or TSOs, also try to lower their losses, because all of their losses need to be procured. You need to buy the energy to cover these losses. And by lowering the losses, of course, you lower the price you need to pay for the procurement of this energy, which actually in the final end leads to more efficient operation of the system. Distribution system actually is the best place to implement all kind of technologies that we presented earlier to achieve a better energy efficiency. So by utilizing all of these smart grid components, we can achieve better efficiency. By operating the system, by using the SCADA systems, by using various devices now that are now available, like control of the reactive power, control of the power flow, voltage regulators, different kinds of efficient inverters for renewable energy sources, efficient chargers which can charge vehicle to grid and both grid to vehicle. In the grid, we can operate our distribution system in a way that finally we also have low losses. So also the distribution system operator are procuring energy for the losses, and in their interest as well is to have lower losses and finally better energy efficiency. Customers are also one important piece of the puzzle in this whole story. So customers actually can adapt their cycle of energy use throughout the day in a manner to be more energy efficient. However, this needs to be backed up by some financial incentives, such as demand response, loads, demand and response tariffs, as we can see on the right side. So customers, by different tariffs, may be encouraged to use energy in the different periods of time that in the end will lead to more efficient utilization of the grid. Of course, operations, which are day-to-day work that all system operators do, such as data collection, monitoring and control, and analysis of this data. Now, by having a lot of these sensors, new metering devices, and communication infrastructure, it is quite easy to obtain a lot of data, but it is hard to analyze this data. However, by efficiently analyzing, we can make more efficient actions, and we can operate the grid in a more efficient manner. And finally, the market, the energy market, is a key component as well, because as soon as you have money as part of the story, the energy efficiency rises. So currently, as we said, the energy is a commodity and it is on a market. So for us, maybe the most interesting is the retail market, which is in Europe quite developed, still not that developed in our country. But we do have different suppliers. You can choose who do you want to buy your energy from. And there are different stakeholders in this market, and all of them have one thing in common: to sell and transport the energy in an efficient manner, because nobody wants losses, and that in the end leads to the more efficient way of operation. Service providers, of course, are also one way to improve the energy efficiency. Service providers such as different suppliers, different distribution system operators, they may offer different services to their customers in order to improve energy. So on the right side, you see an energy meter, a tablet that shows you your energy, which actually a company from the UK is using to promote energy efficiency for its users. On the left side, you see a quite new concept called virtual power plant, where a service provider called aggregator aggregates different smaller power plants, for example, these 4 houses, and then sells that energy as a big player on the market. So currently, this virtual power plant is quite developed in Germany, where a lot of houses are actually now on the market, and they are just, for example, they are participating in the market of auxiliary services. So these power plants are actually not producing; they are just in the backup and waiting to be used. And for that, they are charging more than selling the energy. So the whole market around electricity is developed, and of course, the backbone is financial drivers, and in the end, the energy efficiency is very important for all of them. So having all of this said, what is the resulting energy efficiency? If we take a look at the left side of this slide, we can see the energy losses in the distribution grid of European countries. So as we can see, it is dropping because in interest of every of these operators is to actually have lower losses. But if we look at the right side and see a wider time span from 1920s to now, we can see that the transmission and distribution losses are actually falling. It is estimated that it will continue to fall according to this trend. And of course, European countries are best in the world in this energy efficiency because they have the latest technology and the best grids. But most of the other countries follow this trend as well. So to conclude, all of these new technologies within the smart grid, all of these financial incentives, market, consumers, all of the stakeholders that work together in the grid that is now actually smart, and it's called smart grid, have in the result a good energy efficiency, and this energy efficiency with the development of the technologies will most certainly improve. So thank you very much for your attention, and I will be really glad to hear your questions.
So thank you very much, Dr. Kuban. If anyone from the public have a question, now is the time to ask our panelists.
Thank you very much, Dr. Tarek. And Amina, first of all, Amina, thank you very much for organizing this. And it's really, as usual, perfect. And Dr. Tarek, it was really an amazing presentation. I mean, I was quite excited that I just pushed the button on Facebook to say how exciting and amazing your talk was. So, and actually, it is very important when you're covering such topics to make them simple for the public. And this is one of the series of webinars that next week will go public to all our students and the wider public in 13 different countries, and it is really important to understand without intimidating the audience. I have a question because I live in a smart home and I'm trying to have smart gadgets everywhere, and I have my meter, and actually I have to say that when I had my smart meter for the first week, I was spending almost every other minute looking at it, or actually I looked at it more than I looked on the TV, especially to see how much I was consuming energy, especially during the washing with the washer dryer, which is like, it was a reality check for people, how much it can cost. So how do you think that this will affect the culture of people, especially in different countries, if you can compare? Because I think there must be a cultural shift, yeah? I mean, we must change the way that we perceive that commodity, which is energy, because I don't know if that has come to your country already, but we've seen it in several countries after COVID, how the prices, especially of natural gas, and they're going to be increased, and they're going to be affecting the entire market. So how will this affect the way people perceive energy consumption, and what can we do in order to become a habit of them, not to forget it, but also to be aware, and by using a smart grid to realize that they can change their habits and change the way they consume energy? Thank you.
So that's a really good question. And for the first part of the question, we also have smart meters here, but the end consumers are not quite aware of all the possibilities that they can obtain from these smart meters. For example, you can constantly check your consumption. You can even ask your monthly load curves at the end, so you can analyze your consumption. Most of the European countries where the energy market is more developed and where the prices of energy are higher, they have different suppliers on the market, and currently all of these suppliers are offering a service of energy monitoring in some kind of the way. So either through this tablet form I showed in the presentation, or through online portal to monitor your energy. And the first step in the world of energy efficiency is, of course, the measurement, because you need to be aware how much of energy you're spending. When you are fully aware of how much energy you're spending, then you can change your habits. The next step would probably be some kind of demand response tariffs or dynamic tariffs with where consumers can interact with the supplier. So then the next step in a smart home, for example, that's one of the reasons why smart homes are important. In those setups where price of energy changes over the day, smart homes can intelligently adapt the consumption in order to have the lower bill at the end of the month. So you are right. The energy monitoring is one of the key features that leads to energy efficiency. And also in these times, all of us were quite aware how energy is important in our lives. And therefore, we started to value a little bit more all kinds of energy.
Thank you very much. I usually ask 2 questions, but that was a very long question and a very long answer. So I don't know, Amina, yes, has one.
Thank you very much, George. Does anyone else wants to ask the question? No one? Okay, then, Tarek, thank you so much for this great presentation. Thank you for these explanations about the grids and etc. It was very nice to hear these new things. I hope that other people enjoyed this session, and I hope that other will see it on our YouTube channel. So thank you very much for this.
You are welcome. I hope I managed to clarify in the simple way some of these quite complicated terms.
Yes.
Dr. I have to say that you managed so well that I'm hoping that we can have you again. We're definitely going to invite you for another talk, especially during the micro lessons we're going to have in October. And we're waiting to hear of the involvement we will have in COP26, which is going to be an amazing opportunity if we manage to get there and present our lovely project. Amina will hopefully get the link for the recording so we can upload it on YouTube and the attendance list. And again, Dr. Tarek, I cannot thank you enough. Thank you very much, Mosta, for organizing yet another very interesting, very enlightening, and very successful presentation and webinar. Thank you.
Thank you so much, and bye-bye.
Bye.
Bye.
Thank you. Bye.